Hello, my name is Abdul Rahman and I am here for the video presentation of my research method coursework in which my topic is deep sequential skin cancer classification network. In this work, I explore how to deep learning techniques, especially CNNs and the transformers, can be used to build a highly accurate and responsible AI model for the skin cancer detection. For the introduction, skin cancer is one of the most prevalent cancer worldwide if it diagnosed early. It's highly treatable, however, manual diagnosis can be prone to error and variability between the dermatologists. That's why I proposed a deep sequential network that merged the conventional neural network CNNs for future extractions and the transformer for capturing the sequential patterns. This hybrid model aims to provide the better diagnostic accuracy. The thing which make it more impactful is that it is designed responsibly by integrating the ethical, legal, social, and professional consideration um, I refer to as the LSEPI framework to ensure that the AI respects the privacy, fairness in a very depth. Next is the research methodology. Now we see how this research was designed. In this research, I used a hybrid model CNN to extract the virtual features from the skin lesion images and transformer to interpret these features sequentially. The dataset which I used was the ISIC 2020 dataset, which contain high quality demographic images of various skin lesions, all ethically sourced with the proper approvals. In the data processing stage, I applied technical techniques like resizing, normalization, image auto augmentation, and segmentation. These processing steps were crucial to improve the model's robustness and its ability to generalize across the different skin types and the lesions variations. Next is the technical approach. The technical backbone bone of this model is the combination of two architecture, the CNN module and the transformer module. The CNN module, this is responsible for the scanning the images and the extracting relevant pattern like edges, color textures, and the irregularities. For the transformer module, this processes these feature in the sequence, leveraging the attention mechanism to determine what part of the image are most important for the classification. Next is the testing strategies. To evaluate the model, I used various performance matrices, such as accuracy to check the accuracy and the overall correctness, precision and the recall to measure the class-specific performance, F1 score to balance between the precision and the recall, and ROC AUC curve for the binary classification quality. And to make sure the testing process robust, I use 70 15 15 train validation test split along with the cross validation. The next is the limitations. Despite promising the outcomes, there were a few challenges. First, the dataset diversity was limited, which may introduce biases, particularly across the skin tones. Secondly, the computational cost of the combining CNN and the transformer was high, requiring powerful hardwares. Lastly, implementing the explainability techniques so that the doctor can understand the model's decision was technically complex. In the future, I plan to include more diverse data sets, explore the lightweight transformer models, and improve the explainability by using the technique like Grand CAM. Next are the ethical issues. Ethical consideration were the center of this project. I address bias mitigation by attempting to balance the data set and ensure the representation of all the demographics. For the transparency, I aim to provide the visual explanation of the model predicting to assist the clinical decision making. In terms of the data privacy, all the data set used are publicly available and comply with the GDPR and the medical data ethics as guided by the Navigate and von dem Bruche framework. This ensured that the model does not just performing well, it also behave responsibly. To conclude, this project present a novel for the deep learning approach for the skin cancer classification by combining the CNN and the transformers. The model achieve high accuracy and the contextual understanding. But for the next chapter, upcoming chapter, the next phases of my project will involve the following chapter. Chapter 4, implementation and the result. In this, I will train the final model to generate the visual output like confusion matrices and the heat maps and compare its performance to existing model to validate the improvement. In chapter 5, which will be the discussion, this chapter will interpret the result in detail, revisit the research objectives and reflect on the both technical performance and the impact of the ethical consideration. And further in the chapter 6, which will be the conclusion and the recommendation, I will summarize the overall contributions and propose the future directions such as deploying the model as a mobile or web application and improving the explainability for the clinical adoption. These steps will bridge the gap between the academic research and the real-world healthcare applications. This is all about my video presentation for the research method coursework. Thank you very much.